Measurement. Shakespeare wrote a play called Measure for Measure, which really doesn't have anything to do with what we're talking about, except to say that being right is better than being wrong. Good thing there are rules for significant figures, which you can read about and practice and follow. This video is about where those rules came from, why they are not arbitrary. Consider this purple rectangle. Control C, Control V, two of them, and two rulers. How long are they? The rectangles, not the rulers. Zoom in and, that sounds good. How about the twin rectangle? Being careful, I'd say this, which is different, but also strangely the same. The same in that all measurements have some degree of uncertainty. So you cannot say that this one is right and that one is wrong, or that this one is good and that one is bad. You could say that this measurement is more precise, more exact, but you'll never be able to call it exact. More exact, okay, but not exact. All measurements have uncertainty. This one has more uncertainty. That one has less uncertainty. That's how they're different. Here's how they're the same. The same length. Hold the phone. Isn't that bigger? This calculator thinks so, but the calculator is wrong. You enter this and it sees that. Because your calculator does not know about measurements, how they all have uncertainty. It leaves out the uncertainty. This is a better picture, and that's why you can't say one measurement is bigger than the other. Don't forget, it was the same rectangle, even if these two are different measurements. Wait. How can you be certain about uncertainty? I've got you there. Easy, though. It's a definition. Definitions are certain. So I'm not saying you can never know anything about anything, or you can never be certain about everything, or that all measurements are equally valid. I'm not saying any of that. All I'm saying is that measurements have uncertainty. If that makes some sense, I have a quiz question for you. Find the length not of a purple rectangle, but of that. Gosh, what might it be? Well, whatever it is, I hope you agree that there's some uncertainty. We don't know the length of this piece of fabric to the 10 millionth of a centimeter. Measurements have uncertainty, which means rounding. Rounding is necessary, but dangerous. Necessary if you are finding the area of this table, measuring length and width and finding area. But wait, that's not what the calculator said. But that length you measured, it had uncertainty, and so did the width. The area value is really a range of possible values. Even if you are confident in your width and your length values to the nearest centimeter, that does not mean you can be confident in the area to the nearest centimeter squared. Rounding is necessary, but it's also dangerous. Here's a challenge. Where will it land? Use the equation and those values. That is the answer. Here it is on a meter stick, and here is what you would get if you were lazy and rounded the velocity and the time values too soon. Rounding, when necessary, needs to wait for the final step. Here's what you get if you rounded incorrectly. 3.26 is closer to 3.3, not 3.2. Don't just cut off digits when you round. Rounding is dangerous if you want to hit the target. Another problem, but the same idea. It's a multiple step problem, a good problem. It uses two good equations. Step 1, Step 2, Step 3. Student work, acceleration cut in half and the new time. Another student, acceleration cut in half. And a third, all following the same steps but getting different results because rounding is dangerous. In this case, the blue answer is the best. I'd prefer that, though, because rounding is dangerous. Also, it is necessary because all measurements have some uncertainty. So how can we get the best, the most precise, most trustworthy, most reliable values possible? Well, use the best tools and techniques, obviously, but also by taking multiple measurements as shown here. Our measurements should agree. In this case, we are finding density, measuring mass and volume, several trials, being careful, working towards an answer in which we can be confident.
An Angelo for a Claudio. Death for death. Haste still pays haste, and leisure answers leisure. Like doth quit like, and measure still for measure.